All right, everybody. Welcome back to school. Hope your Corona break has been a good one. We're going to get back into where we left off in algebra, and that is an intro to factoring. Now, when we're factoring, we're basically going to separate a polynomial back into a product. If you remember before, you might have 4x times x plus 2. So what we would do is we would distribute that 4x to each term, and we would get 4x squared plus 8x. So now what we're going to learn to do is take that product, take that polynomial, and we're going to factor out a number or a variable or both, and we're going to put that back into a product. When we do that, first thing we can do is check the coefficients. So they have a number that can divide into both of these evenly. And obviously 4 can go into both of these. So now we need to look at the variables. What variables do they have in common? Because remember, they have to have the same exact variables to make them a GCF, or greatest common factor. And of course, we already know in this case, the GCF for this polynomial is 4x. So if I pull 4x out, well, 4x squared divided by 4x, 4 divided by 4 is 1. Remember, when we divide exponents, we subtract them, so we have 1x squared minus 1, which just gives us x. So that first term is x. So then 4x going into the 8x, well, 8x divided by 4x, 1 minus 1 is 0, so that's gone. 8 divided by 4 is 2, and it's positive, so that's why we get this. Same exact answer, okay? So that's what we're working on today. We're going to make sure we follow some steps. Let's write down some basic steps that we're going to follow. So step 1 is identify the GCF of the polynomial. Identify the GCF of the polynomial. Okay? And don't forget, GCF means greatest common factor, which is fancy words for a biggest number that can be divided into each of those terms. Okay? So to identify the GCF, we need to check the coefficients. Remember, coefficient means the number in front of the variable. And we also need to look at the variables. Now, look at the variables. Remember, that variable must be present in all terms to be a GCF. We'll write that down. A variable must be present in all terms to be a GCF. Okay? And if it is present, then we're going to take out the smallest exponent. All right? So then step 2, we're going to divide each term by the GCF. And leave the remaining factors in parentheses. And step 3, we can check our work. We check your work by distributing. All right, so let's look at some examples. So of course, we'll have our examples. So that first example will be 3x plus 12. So step 1 tells us, check the coefficients. This is numbers in front of the variables. This is a constant, so that counts 2. For a GCF. So what number can go into 3 and 12? Well, a lot of the times it'll just be that first number, and in this case that's true. It won't always be that, but a lot of the times that's a good place to start. So we can pull 3, or we can divide 3 into both of these numbers. And then the second part of that first step is we're supposed to look for a variable that might be part of the GCF. And since this doesn't have an x with it, all we can do is factor 3 out. So that means we're going to put 3 outside of the parentheses. And of course, 3 divided by 3 just leaves us with x. And 12 divided by 3 leaves us with a positive 4. So that was step 2 that we just did by dividing each term by the GCF. And we leave the remaining factors in parentheses. Now we can check our work by distributing. We can distribute that 3 to each of these terms. And we should get our original polynomial. And if we do, that means we did it correctly. So let's look at another example for you guys to try on your own. Keeping it simple to start off with, just like the normal classroom. So you can pause it, knock this one out on your own. If I'm looking at this, since there's both 7s there, that means I'm going to divide everything by 7. If you divide that whole thing by 7, then you've just got y minus 1 on top. If you distribute it to check it, you get 7y minus 7. All right. Number 3 example. Let's look at 8m plus 36m. And let's make this one squared. All right, so what number can we divide both of these by? Well, 8 doesn't go into 36, so 8 doesn't work. But I can divide 4 into 8, and I can also divide 4 into 36. And since they both have an m, I can divide it by 4m. So that means I'm factoring out 4m. 8 divided by 4 is 2. M squared divided by m is just m. 36 divided by 4 is 9, and m divided by m is 1, so that one's gone. So my factored form is 4m times 2m plus 9. Step 3, we're checking it. 4 times 2 is 8. M times m is 8 squared. M squared. 4 times positive 9 gives us 36. And that m comes along for the ride, and we end up with the same exact polynomial that we started with.